All right, let's talk about one of the original blueprints for building software. I want you to picture a waterfall. It's powerful, it's direct, and it only flows one way, down. Well, that right there is the whole idea behind the waterfall model. So yeah, let's dive into this structured flow. So what is this thing exactly? At its core, the waterfall model is one of the oldest, most traditional ways to get software built. The best way to think about it is like a very strict recipe. You have to finish step one completely before you can even think about starting step two. It's all about that linear, one-way street from start to finish. And this is the absolute golden rule. It is non-negotiable. Once a phase is done and signed off, that's it. The gate slams shut behind you. There is no swimming back upstream. Now, this is what gives the model its super predictable structure, but as we're going to see, it's also where it gets its reputation for being so rigid. So where did this come from? Well, the whole idea traces back to a 1970 paper by Dr. Winston W. Royce, and his thinking was really influenced by big-scale manufacturing processes. And that totally explains why the model is so heavy on strict processes and documenting absolutely everything. Okay, so now let's actually take a trip downstream and see how this thing works in the real world. We're going to walk through the 6 distinct phases of the waterfall model. And to make it feel real, we'll use a simple example the whole way through. Let's pretend we're building a brand new banking app. So here's our roadmap. We start way up at the top with requirement gathering. Then we flow down into design, implementation, and testing. And then we finally cascade into deployment and long-term maintenance. Each one of these steps is its own little self-contained world. Okay, phase 1. We are at the very top of the waterfall. And this is maybe the most important phase of all, requirements. This is where every single thing the software is supposed to do gets defined and documented before a single line of code is written. So in this phase, the team is basically interviewing everyone involved to figure out exactly what they need. And this stuff gets split into 2 buckets. You've got your functional requirements, like a customer has to be able to log in, and then your non-functional ones, like that login needs to happen in under 3 seconds. Everything gets captured in this huge master document called the Software Requirements Specification, or SRS. And that document, it becomes the Bible for the rest of the project. All right, with those requirements totally locked in, we flow down to the next phase, system design. You can think of this as the architectural phase, where the actual blueprint for the software gets created. So here, the architects are drawing up both a high-level design, that's the big picture, the overall structure, and a low-level design, which gets into all the nitty-gritty details. For our banking app, that means designing the database that holds all the user accounts and literally mapping out the entire screen flow from the second you open the app to landing on your dashboard. It's all planned on paper before anyone builds a thing. Now, with the blueprint approved, we finally get to the implementation phase. This is the moment we've been waiting for. It's where the programmers actually roll up their sleeves and start writing code. Now, the developers take those super detailed design documents and just translate them into working code. They're not making things up as they go. They're methodically building each little piece exactly as it was specified. For our app, this is where the actual login screen gets built, and the back-end systems that handle things like transferring money are created. So once all the code has been written and all the different pieces are put together, the entire system gets handed over to the quality assurance team. We usually just call them QA, for some serious testing. Now, this is so important. The tester's job is to go all the way back to phase 1. They take that original SRS document, the project Bible, and they systematically check if the software we just built meets every single one of those requirements. They'll try logging in with the right password, the wrong password. They'll make sure that when you transfer $50, your balance actually goes down by $50. Anything that fails gets written down as a defect that needs to be fixed. Once the software has passed every single test and the QA team finally gives the thumbs up, we hit the deployment phase. This is the big go-live moment. It's the point where the product is finally released from its cozy development world out into the real world for actual customers to use. This basically means installing the application on live servers and making it available to everyone. For our banking app, this is the moment it finally shows up in the App Store. As far as the main development journey goes, we're pretty much done. But hold on, the waterfall doesn't just stop and disappear. It flows into one final, ongoing phase. You can think of it like a maintenance pool at the very bottom. The software is out there, but the job is never really over. It has to be supported. This whole phase is about reacting to what happens in the real world. Users are going to find bugs that nobody in testing caught, or they might request small improvements. So, for instance, if customers start reporting that our banking app crashes whenever they try to transfer a really large amount of money, the team would jump in, create a patch to fix it, and push out an update. Okay, so we followed the water all the way from the top of the mountain down to the pool at the bottom. So now let's step back and take a look at the view. What are the actual results of this superstructured journey? It's time to weigh the pros and cons. Well, the advantages are pretty obvious, right? It's simple, it's structured, it's really easy to manage. But here's the catch. Its greatest strength, that structure, is also its biggest, most fatal flaw. Because it's so rigid, finding a mistake late in the game isn't just a small hiccup. No, it can be an absolute catastrophe for the project's budget and its timeline. So, given this big trade-off between structure on one hand and flexibility on the other, when is it actually a good idea to go down this particular river? Choosing the waterfall model is a big strategic decision, and trust me, it is not right for every single project. Honestly, it all comes down to one thing. Waterfall is fantastic when you know exactly what you need to build from day one, with zero ambiguity. Think about government projects or building medical devices where regulations are super strict and never change. But you want to run away from it when you're in a fast-moving space, like a tech startup, where your requirements are probably going to change 100 times as you learn more about your customers. Now, I know that modern methods like Agile have pretty much taken over because they're so flexible, but it would be a huge mistake to just write off the waterfall model as some kind of dinosaur. Its impact on how we build software is actually really profound, and it's still felt today. When you get right down to it, the waterfall model's legacy is that it's foundational. It taught an entire generation of engineers the incredible value of discipline, of planning, and of clear documentation. It really brought a much-needed engineering structure to what was, back then, the pretty chaotic art of making software. And that really brings us to our final question. Today, the whole tech world is obsessed with words like agile, pivot, iterate. Speed is king. But does that mean structure is totally obsolete? Or is there still a time and a place where that deliberate, predictable, and disciplined flow of the waterfall is exactly what you need to get the job done right? Something to think about.